In this video, we'll be going over how to solve some basic logarithmic equations. These are logarithmic equations that involve only one logarithm. Let's jump straight into some examples. In example A, we have the equation log with base 7 of 3x equals -1, and our goal here is to solve for x. We call these equations logarithmic equations because they involve a logarithm and the variable that we're trying to solve for is inside that logarithm. Now, there's two ways we can think about solving this. One is we can take this logarithmic equation and convert it into an exponential equation like we did in our previous video. As an exponential equation, we would have the following. Remember that the base of the logarithm becomes the base of the exponential. The answer to the logarithm is our exponent, so we have 7 to the power of -1. And lastly, the thing that we take the logarithm of goes on the right-hand side of the equation. So we have 7 to the power of -1 equals 3x. And by writing our equation in this way, we can easily solve for x by dividing both sides by 3. Another approach is by thinking about how you would get the x by itself. Typically, in an equation, we have operations performed on our variable, and we perform their inverse operations to both sides of the equation to help us isolate that variable. This is how I like to think about these problems. So if we look at our variable x here, what operations are being performed on it? We have a multiplication by 3, and then we take the logarithm of that with base 7. So if I want to get rid of the logarithm, we would need to perform the inverse operation to both sides of the equation. Remember that exponentiation is the inverse operation to logarithms. So to undo this logarithm, what we're going to do is exponentiate both sides with base 7, meaning we're going to do 7 to the power of the left-hand side and 7 to the power of the right-hand side. So on the left-hand side, we have 7 to the power of log with base 7 of 3x. And on the right-hand side, we have 7 to the power of -1. Now, because the logarithm with base 7 and the exponentiation with base 7 are done back to back, these two operations cancel out, and it just leaves me with 3x on the left-hand side. On the right-hand side, 7 to the power of -1, we can simplify that to just 1/7. We see that this approach gives us the same equation as what we did when we converted our logarithmic equation into an exponential equation. The reason why I like exponentiating to get rid of the logarithm is because to me, it's more intuitive, and it's more in line with how you've solved equations in the past. Now, after getting rid of the logarithm, our equation is now 3x equals 1/7. There's still a 3 being multiplied to the x. So if I want to get rid of that 3, we perform the inverse operation, which is to divide both sides by 3. Or we can think about this as multiplying both sides by 1/3. We end up with x equals 1/7 times 1/3. We can combine that together to get 1/21. And x equals 1/21 is the solution to our logarithmic equation. Let's try example B. Here we have log with base 8 of square root of x equals 2/3. Again, we can think about what operations are being performed on the x. We see that we're taking the square root of x, and then we're taking the logarithm of it with base 8. So if we want to undo the logarithm, we would need to perform its inverse operation to both sides of the equation. Again, exponentiation is the inverse to logarithms. So we're going to exponentiate both sides of this equation with base 8, meaning we're going to do 8 to the power of the left-hand side and 8 to the power of the right-hand side. So we end up with 8 to the power of log with base 8 of square root of x equals 8 to the power of 2/3. Now on the left-hand side here, because the logarithm with base 8 and the exponentiation with base 8 are performed back to back, these two operations cancel each other out. So on the left-hand side, we'll just be left with square root of x. And on the right-hand side, we have 8 to the power of 2/3. Let's remind ourselves how we would compute something like 8 to the power of 2/3. First of all, we'll still have square root of x on the left-hand side. On the right-hand side, we're going to think about this 2/3 power as 1/3 times 2. What we're going to do next is use an exponential property. Remember that if we have a to the power of m and it's raised to the power of n, this simplifies to a to the power of m times n. What we see here, 8 to the power of 1/3 times 2, is like the right-hand side here. And what we're going to do is rewrite it so that it looks like the left-hand side. So what do we have? We have square root of x on the left-hand side, and we're going to think about the right-hand side as 8 to the power of 1/3, and then this whole thing squared. Next, we're going to use another exponential property. Remember that if we have a to the power of 1 over m, this is the same as taking the mth root of a. So 8 to the power of 1/3 is like taking the cube root of 8. So we have square root of x is equal to the cube root of 8 squared. Now this is something that we can compute. The cube root of 8 is just 2, and then if we square it, we end up with 4. So our equation is square root of x is equal to 4. Now, if we want to get x by itself, we would need to undo the square root. And so we perform its inverse operation to both sides of the equation. We'll square both sides of this equation, and so on the left-hand side, we'll just be left with x, and on the right-hand side, 4 squared gives us 16. And so x equals 16 is our solution to this logarithmic equation. Let's try example C now. Here we have log with base 2 of 4x minus 3 equals 5. Again, if you want to get rid of the logarithm, what you'll do is perform its inverse operation to both sides of the equation. The inverse to logarithms is exponentiation. So we'll exponentiate both sides with base 2, meaning we're going to do 2 to the power of the left-hand side and 2 to the power of the right-hand side. This gives us 2 to the power of log with base 2 of 4x minus 3 equals 2 to the power of 5. Because we have inverse operations being performed back to back, they cancel each other out, and that leaves us with 4x minus 3 on the left-hand side and 2 to the 5th power, which is 32, on the right-hand side. There's still operations being performed on the x here on the left-hand side. There's a multiplication by 4 and a subtraction by 3. To undo the subtraction by 3, what we do is we add 3 to both sides. That's going to leave us with 4x equals 35. And lastly, if we want to undo the multiplication by 4, we divide both sides by 4. So this leaves us with x equals 35 over 4. So x equals 35 over 4 is the solution to our logarithmic equation. So in this video, we learned how to solve some basic logarithmic equations. The key takeaway is that exponentiation is the inverse to logarithms. So if you want to undo a logarithm, you exponentiate both sides of the equation using the same base.